Now the introduction to Java. The Java is, as we know, that it is an extended version of a C++ language. Okay, C language was a base. So the logic of the C, Java, C++ are all the same. Only the grammar of the language changes, right? The grammar of the language differs from C to C++ and C++ to Java. Okay, C is a basic language which is where it is built where C++ is built on a C language, because C, the name itself C++, right? That is a plus plus is an increment operator in C and as well as a C++, right? So the extended version of a C is a C++. Then the Java is a extended version of a C++. See, the C is a procedure oriented program and C++ is it supports a object oriented program and it also supports a procedure oriented program. So we call that C++ is a extended conventional language, we call it. Okay. Now, whereas the extended version of a C++ is a Java programming. Okay, Java is a pure object oriented programming, right? It does not support any procedure oriented program. It is purely the object oriented program where the grammar of the Java programming is going to work only on the objects and the classes. Okay, now so when we say that Java is a pure object-oriented program, we must understand the basic concepts of object-oriented programming. That is the base properties of an object-oriented program. The properties of an object-oriented program before proceeding to the Java programming language. The basic concepts of object-oriented programming is, say, object, class. There are 9 properties of the object-oriented programming concepts. First one is object, second one is a class, third one is data abstraction, fourth is data hiding, data encapsulation, right? Message passing, dynamic binding, polymorphism, okay? And the next is the inheritance. Okay, so this is about the we can say that it is about the concepts of object oriented program. So we'll study the very important part of the object oriented programming, that is a concepts of object oriented programming is that is about the objects, classes, inheritance, data hiding, polymorphism, data encapsulation, data abstraction, right? Then the message passing and the dynamic binding. Okay, these are all the concepts of the object oriented programming, because before proceeding to the Java, we must understand how this Java is going to support all these features of the object oriented programming concept. Okay, now so we'll study the different that is the object oriented programming concepts. First one is we call, as I told, the object. So, okay, so now so objects are the basic runtime entities, we can say, okay, or object oriented program. So these, as we are familiar with the variables, right? What do you mean by variables? So variable is the one which is going to change its value during the execution of the program is called as the variable. Okay. So this object is a basic unit of the object-oriented programming, or in simple, we can call this object is an runtime entity. Okay, and or you can call it is a class variable. Okay, So we are going to, I told that object oriented one of the feature or one of the concept is a class. So when we are going to use a class, right, that class is contains we have discussed in the previous section, that access specifiers private section data, public section data, and the protected section of the data, right. Now your there are some data members and member functions in a class. So what do you mean by class? Class is a user defined data type which allows the user to define the both member functions as well as the data members. That is a, it is a class is a extension of structures, right, where in structures all the members are by default they are public, whereas in class, since it is a feature of object oriented programming, it supports the private section of the data by declaring some of the variables under the private section of the data, that we call it as a data hiding or data security, right. So when we want to access these members, say for example, class allows the user to declare variables as well as the functions. So variable which we are going to declare and the class is called as a data member, and the variable which you are going to declare function which you are going to declare under class is called as a member function. Okay. Now the so when we want to access these member functions and the data members outside the class, we have to say that this particular member function or the data member or base belongs to this class, right? So when we want to access the member functions for execution, for invoking, or when we want to assign some values, or when we want to access the values variables data or the data members of a class, we use a objects. So okay, that is called as a class variable. So you people are familiar in the structure, that is a structure variable, right? What is the purpose of creating the structure variable under the struct heading? It is going to use for accessing the members of its class, members of the structure, right? Similarly, in classes also, when we want to access the data members or the member functions, we want to declare the objects. These objects are used to invoke the or to access the member functions and the data members. That is both data and methods. So in Java, we never call the functions as a member functions. We call them as a the methods, right. So that is both data and methods that operate on data are bundled as a unit, it is called as a object. So whenever we are going to create one object, that always holds the data of a member function as well as the data member values and the member functions. As we have discussed that the sharing of the memory or allocation of the memory space for an object is the each object will have its own space for the data members, right? But objects are going to share the member functions. That means what I want to say is, say for example, you have created 4 objects, right, and 4 variables are there. All the 4 variables will have the separate memory allocation for each object. Listen carefully, right? And member functions, all the 4 objects are going to share the member functions. Okay, that is a one memory space is created for each member function, and that member function is going to share with all the 4 objects. But there will be a separate memory location for each data member in a for each object. Okay. Now it is, we can call it as a real-time entity. Example, say a person, book, tables, chairs, etc. We call that this is called as the object. Okay. So it is a runtime entity, or we can call it is also called as a, they may represent a person, the object may represent a person or a place or a bank account or a table of data or any item that the program has to handle. They may also represent user defined data like vectors, time and list. So when a program is executed, the objects interact by sending messages to one another. Okay. So that means what I want to say is, in terms of objects and nature of communication between them, program objects be chosen such that they match closely with the real world objects. As I told, they take up the memory memory space and have an associated address like a record in the structure and in the Pascal. Okay. The objects can interact having to know the details for each other's data and or code. It is sufficient to know the type of the message accepted and the type of the response returned by the objects. Different authors are going to represent them in a different way, notations. Okay. So we call that is the two objects. Customer object may send a message to the account object requesting the bank balance, right? For example, if you have a bank database, the bank database will have the account number, okay, and the balance of an account holder and name of an account holder, right? Suppose I am going to create three functions, say open account, okay, deposit amount and withdrawal amount, finally display. Okay, so I am creating only one object to access all these member functions. This object is going to communicate with each member function. Okay, so opening balance, so it is going to accept from the open account, and that opening balance is going to be sent it to the deposit amount function. In turn, whatever the amount we are going to deposit, that is going to be added with the current balance. That communication is done through the objects. Okay. Now, the withdraw. Say for example, after depositing the amount, there will be some balance amount, right? That object is going to communicate with the withdraw function. So this is what the current balance of the account holder. In turn, when the customer is going to withdraw the money, then the withdraw function will have two conditions. One condition is that, so when the user is going to enter some amount, it is going to test whether that amount is exceeds the current balance, or that it allows the user to withdraw the money. So what is the condition? If the withdraw amount is greater than the current balance, it is going to give the message you cannot withdraw because your current balance is lesser than whatever you are withdrawing, right? The other option is, suppose the user has given the withdraw amount less than the current balance. That time it allows the user to withdraw the money, and that withdraw money will be deducted or subtracted from the current balance of the open account. Then the rest of the amount will be saved as a open balance amount, and that balance amount is going to communicate with a display function to display what is the current balance of the account holder. Okay, for example, say your opening balance is 10,000, you are depositing the amount is equal to 5,000. So what is the total amount? Your current balance will be 10 plus 15, 15,000, 10, 5, 10 plus 5 will be the 15,000. Then when you are going to withdraw a 20,000 amount, then it will give the message you cannot withdraw the money because the current balance is 15,000 and your withdraw money is more than that. Okay. So other condition is, suppose the user is going to opening balance, the current balance is 15,000. When you withdraw the amount of 5,000, then it allows the user to withdraw money because the current balance is more than what the withdraw money. So in that way, the objects are going to communicate with each member function of its own class. Okay, that is the duty of the objects. Now the other second is the class. So that is another concept of the object oriented programming. Second concept will be the class. So class plays very vital role because that objects contain the data code to manipulate that data. The entire set of data and code of an object can be made a user defined data type with the help of a class. In fact, objects are variables of type class. Once a class has been defined, we can create any number of objects belonging to that class. Each object is associated with the data of type class with which they are created. So we can define a class is a collection of objects, or class is a collection of instance variables, so which all the elements or belongs to the similar kind, instance variables and methods. When you want to define a class, you define a blueprint for an object. This does not actually define any data, but it does define what the class name means, that is what an object of the class will consist of and what operations can be performed on such object. Okay, for example, you take the mango, right, apple, orange, okay, then are members of the class fruit. Okay, classes are user defined data type and behave like a built-in data types in a programming concept. Okay, the syntax used to create an object is no different than the syntax used to create an integer object. Okay, so it has been defined that the statement fruit mango will create an object mango belonging to the class fruit. Okay, until the time that is the until we are going to declare that the fruit is a class and mango is an object. So you can create any number of objects of the fruit class. So I can create orange, I can create banana, like that. Okay, now uh, so that is what an object of the class will consist of and what operations can be performed on such object. Then next property is a data abstraction, data hiding, data encapsulation. This all comes under the class itself. Okay, why I am telling is the the uh, object oriented programming allows the user to define both class and the functions in a single unit called as a class. That wrapping up of both the things in a single class, we call it as a data encapsulation. The wrapping up of the data and functions into a single unit, it is called as a data encapsulation. Data encapsulation is the most striking feature of a class. Data is not accessible to the outside the world, and only the functions which are defined and declared in the same class can access it. These functions provide the interface between the objects of the data and the program. This insulation of the data from the direct access by the program is called as a data hiding, or it is also called as an information hiding. I can tell you the property which is called as a data hiding property. Okay, data hiding, that is a some of the variables which you are going to declare under the class declaration. Okay, that is called as a data hiding property. Some of the variables which you are going to declare under the private section of the class, it is called as a data hiding property. Okay, data encapsulation is in a single unit of class we are going to allow the both declaration of the data members as well as the member functions. It is called as a data encapsulation. Come to the data abstraction. So data abstraction refers to the act of representing the essential features without including the background details or the explanations. That means the outside world and hiding their background details, represent the needed information in the program without presenting the details. For example, a database system hides certain details of how data is stored and created and maintained. Similarly, C++ classes provide different methods to the outside world without giving it internal details about those methods and data. So, okay, that property we call it as a data abstraction. For example, you take a list of abstract attributes like size, weight, and cost, and the functions operate on these attributes. They encapsulate all the essential properties of the object that are to be created. The attributes are sometimes called as a data members. As I told, the variables or the attributes we call it as a data members because they hold the information. They contain the data. The functions that operate on these data sometimes called as a methods or they're also called as a member functions. In C++ we call them as a member functions, whereas in Java we call them as a methods. Since the classes use a concept of data abstraction, they're also known as abstract data types, ADT we call it as. So you understood data encapsulation, data abstraction and data hiding. Don't get confusion. Data encapsulation is allows the user to declare both uh, data members as well as the methods. We call it as a data encapsulation. Data hiding is declaring the variables and some of the member functions under the private section of the class is called as a data hiding property. Data abstraction refers to the providing the essential information to the outside world and hiding their background details. Okay, so how we are going to operate the data, okay, how we are going to create the data, how we are going to store the data, will not give that features, right? Only we are going to use create some of the attributes, that is the data variables or the data members, and we are going to operate on that data using some member functions. Okay, that kind we call it as a data abstraction. Okay, next is the property called as a inheritance. Very important property because this inheritance plays very important role in object oriented concept. So one thing I'll tell you, there are two kinds of languages. One is object based language, the other one is object oriented language. So what is the difference between the object based and object oriented is the object based language only the objects, classes and data hiding property will be there, whereas in object oriented programming the object based features plus it supports inheritance and dynamic binding. So okay, whichever the language, whether Java or C++ or Eiffel, one more object oriented programming language is called as Eiffel, EIFFEL. Okay, so whichever the language which supports both the uh, which supports the feature of object based language plus inheritance and the dynamic binding property, we call it as the object oriented program. That is the reason why I am telling the inheritance plays very important role in object oriented programming. One of the most useful aspect of this object oriented programming is reusability. So whatever the program you are already written, that can be reused once again. Say for example, I'll tell you, inheritance is a process by which objects of one class acquire the properties of the objects of the another class. It supports the concept of hierarchical classification. For example, you take a bird, okay, so bird will have the attributes, they will have the feathers and they lays the eggs. Okay, and the bird again classified into two. One is a flying bird, other one is a non-flying bird. So when you take a flying bird, that will have its own attributes, right? When you take a non-flying bird, it is having its own attributes. Okay, but both the birds will have the feathers and they lay the eggs. Okay, then for example, you take a robin is a part of the class which is comes under the flying bird. which again part of the class called as a bird. The principle behind the sort of division is that derived classes share the common characteristics with the class from which it is been derived. In OOP, the concept of inheritance provides the idea of reusability. This means that we can add additional features to an existing class without modifying it. This is possible by deriving a new class from the existing one. The new class will have the combined features of both the classes. The real appeal and power of the inheritance mechanism is that it allows the programmer to reuse a class that is almost but not exactly what he wants, and to tailor a class in such a way that it does not introduce any undesirable side effects into the rest of the class. So note that each subclass defines only those features are unique to it. Without the use of the classification, each class would have explicitly include all of its features. Okay, that is about the inheritance. It is very important concept of object since this feature helps to reduce the code size. It saves the time. Okay, and debugging time it saves, rewriting the code saves the time, right? And that program whatever we have that can be extensible. Okay, next property we have, this is a very important property called as a polymorphism. Okay, polymorphism is nothing but the important concept of this object oriented program. Polymorphism, it is a Greek term which means the ability to take more than one form. An operation may exhibit different behavior in different instances. The behavior depends upon the types of the data used by in the operation. For example, consider the operation of addition of two numbers. The operation will generate a sum. If the operates on strings, then the operation would produce a third string, which is called as a concatenation of the two strings, right? The suppose if you are going to enter two integer variables, then addition of two integers. If you send a two floating point, then it is addition only, but it is different floating point numbers. Suppose you are adding one float and one int, it is a different variable, right? So we call polymorphism is the one which is going to accept the different parameters for the same function name. So polymorphism plays an important role in allowing the objects to having the different internal structures to share the same external interface. This means that a general class of operations may be accessible in same manner even though specific actions associated with each operation may differ. Polymorphism is extensively used in implementing the inheritance. Say for example, you take a shape, draw. Draw is a method, right? I can use a different drawing. Circle, I can draw a circle, I can draw a rectangle, I can draw a triangle also. Okay, so it is called as a polymorphism. So single same function name but different parameters we are using, but we are going to use a different. Okay, this is about the polymorphism. Okay, so normally the polymorphism is also called as a function overloading. Function overloading means, so what we have studied, the constructor overloaded, same constructor with a different parameters, so we call it as a overloaded constructor. Here also, when the same function name with a different parameters, when you are going to use, it is called as a function overloading, or it is also called as a function polymorphism. Okay, because same function name, say you take example sum. Okay, you are going to send the two parameters, two integers. Okay, and two floating point numbers or two strings, or one float and one double, or one float and one integer, like this. Okay, but function name will be the same, different parameters, so we call it as the function polymorphism or the function overloading. Okay, polymorphism is also a the another kind of the function overloading. Okay, so same function name but with a different set of arguments. Okay, so next another two features we have, the dynamic binding and the message passing, that I will do in the next class.